World Spaceflight News Special Report. NASA provided an informative update about plans for a Mars sample return mission later this decade. The joint campaign with the European Space Agency will be very complex. It is designed to return the titanium sample tubes now being collected by the Perseverance rover. With Percy mission scientists proclaiming their enthusiasm about the importance of organic-rich rock samples just collected by the rover, the team is reviewing plans to deposit select tubes at a retrieval cache site near the base of the Delta in about 2 months. The new samples are said to be the most important samples to be collected on the highly successful Percy mission. Lori Glaze, director of the NASA Planetary Sciences Division, along with others on the NASA panel, explained the sample return plans. Here are the key excerpts of the September 15 Mars Science Press Briefing.
So let's talk just a little bit about what's going on with that next phase of the Mars sample return campaign. We've recently made some changes to the campaign design, and if I can get the first image there, you can see our Mars sample return family portrait. Mars sample return, of course, this is a strategic partnership with the European Space Agency, and it'll be the first mission to return samples from another planet, and also the first to launch from the surface of another planet. The samples to be returned, those that are currently being collected by Perseverance now during its exploration of Jezero Crater and its ancient river delta, those samples are thought to be the best opportunity to reveal the early evolution of Mars, including the potential for life, as you've already been hearing here today. In this image, you can see Perseverance, who's not only collecting samples, but can be utilized to deliver the samples back to the sample return lander. In fact, based on a new assessment of the reliability and life expectancy for Perseverance, we now have increased confidence that the rover will be able to deliver those samples to the lander in the 2030 timeframe. That lander, the lander that we're going to deliver the samples to, is going to carry a payload that includes 2 sample retrieval helicopters. Those helicopters are going to build on this incredible experience we have with Ingenuity. And those little helicopters will be able to retrieve the samples that are left on the surface at the caching depot that Rick was just talking about. The lander will also carry the Mars Ascent Vehicle, which will place those samples into orbit around Mars for capture by the European Space Agency's Earth Return Orbiter. So we're making tremendous progress in maturing our plans for Mars sample return. And if I could have the first video clip, please. This video is showing some testing that's going on in JPL's Mars Yard with the Perseverance test bed known as Optimism. The goal of this set of tests was to practice dropping the sample tubes from the adaptive caching assembly to the ground on variously tilted terrain. This is the same procedure that'll be used when we drop the tubes on Mars. And this allows us to then design and test the systems, those systems, so that we can successfully pick up the samples from the surface. And if I could have the next video clip, please. This video is showing some ongoing testing of the updated sample return lander landing gear. This test, using a 3/8 scale model of the sample return lander, was specifically aimed at the legs supporting the lander structure with impact speeds of about 1.5 to 2.5 meters per second. These tests are still ongoing. The latest test just took place a week ago. And the approach with this testing is to carefully construct the physical tests in the physical world and then construct the same exact tests in a computer model. And that way, we can make sure that the computer simulation matches what happens in the real world tests. And then that lets us know that the computer model is correct. And we can use that computer model to simulate thousands of landings on different slopes, rocks, ground types, orientations, to understand and predict how the lander would behave on Mars. So looking to the future on MSR, there's a few things coming up in the near future. Just next week, we'll be testing the thermal protection material conductivity out at the Ames Research Center. Also in September, on the 28th and 30th, we'll be holding a science workshop that's open to the public to discuss ideas about the deployment of the MSR cache depot. So there'll be a lot of discussion about that caching activity. And then following that workshop on October 19th, there'll be a go, no-go decisional meeting that'll confirm that we are ready for dropping those samples at the depot. In November, a little bit further on the horizon, the European Space Agency's member state ministerial meeting is going to happen. At that meeting, we expect our partners, the European Space Agency, that they will finalize their architecture decisions for Mars sample return. So I mentioned earlier, we've been saying that the Mars sample return campaign began with Perseverance's exploration and the first sampling at Jezero. And what an amazing story those samples are telling us. Not only the Wildcat Ridge samples, but the entirety of Perseverance's samples are intriguing, which means they're perfect for Mars sample return. Perseverance collected both water-deposited rocks and igneous rocks, leading to a highly diverse sample suite. And that diversity is central to the objective of Mars sample return, because the more diverse the sample suite, the more diverse the science investigations the samples are going to support. We expect to have 2 launches from Earth later this decade. The Earth Return Orbiter that'll carry the samples back to Earth is expected to launch in 2027 in our current design. And the Sample Return Lander will actually launch a little bit later, a few months later, in the spring of 2028. It'll arrive on the surface of Mars and spend a relatively short amount of time, hopefully, with Perseverance bringing samples, delivering them to the rover, or having the helicopter pick them up and bring them back to the lander. And then we will launch those samples into orbit around Mars. This will all happen around 2030. And then it begins the trip back to Earth. And we expect those samples to be back on Earth in 2033. Curiosity has already gone more than 10 years and is still going strong. And so we expect that Perseverance will likewise be able to still be operating in very, very good condition when we need to have those samples delivered in 2030. So what the plan is right now, you heard us discussing, you heard Rick talking about potentially dropping as many as like 10 or so samples on the surface in a caching depot over the next several months. That would happen down here in front of the river delta. We know we have a good landing site for the sample return lander in this area. It's very smooth, it's very flat, it's very even. It's a great place for the lander to land. And so kind of as a backup plan, we want to make sure that we're leaving some samples here that we know for sure, if anything happens in the future that would preclude us from being able to get the samples back using Perseverance, we've got this backup cache depot on the surface. And so we're sending, as we're designing the lander, we're including the helicopters, again, as kind of this part of this backup plan, that if we end up landing in a place where we need to pick up samples from the surface, from the cache depot, we'll have those 2 helicopters. I believe each of them can carry back as many as like 15 tubes. So we'd have more than we need for this particular cache depot. But that's kind of the backup plan. The main plan is that Perseverance will still be going strong. It may, as you heard from Rick, it may be outside the crater. It may extend out and go start exploring outside of Jezero crater. And, if we can find a good place for the lander to land up there, we'll be looking, of course, and hopefully Perseverance still going strong. Then we can land the sample return lander near Perseverance, and Perseverance can just drive over and drop off the samples there at the lander. Not just the duplicates of the ones that'll be at the cache depot, but all of the extra samples, the additional samples that we intend to keep collecting as we continue our exploration. So that's the baseline plan, that we would be able to use Perseverance and that we would drop the lander, deliver the lander somewhere near Perseverance so that we can use Perseverance. But again, if something else were to happen along the way and for some reason we thought Perseverance perhaps was not going to be able to deliver those samples, we might consider a second caching depot at another location. But that's a decision for much further down the line. Right now, as I said, Perseverance is our prime option, and the helicopters at this cache depot we're talking about near the Delta Front is our backup option. But we do not need a capability as big as SLS or even as big as Starship. So the spacecraft that we're going to fly there can be launched on existing capabilities. And so we will run that competition like we always do for every interplanetary mission. We compete those, and then we'll select the best launch vehicle and launch provider through that process. And it'll launch from Earth, and it'll launch just as our normal interplanetary missions launch from Earth.
Right. One of the great things about having done this technology demonstration is now we have information of how the helicopter really behaves on Mars, right? So we actually know the flight performance, we know the margins, how much it can carry, and that allows us to actually know that we can pick up a full sample tube and actually be able to transport that the 100 of meters between the depot back to the lander, and do it one at a time would be the plan to do that. And so the idea is to leverage the Ingenuity design as much as possible, right? Because it's the proven design. And we think we can do that. So we really don't think there's a lot of new technology here. The helicopter does have to have one little sort of new feature. It has to be able to sort of scoot around to get close to the tube. And so we are looking at putting small wheels on the bottom of the legs of the helicopter. It's going to be able to land very close to the tubes, but still need to do that final maneuvering to be able to pick them up.
Yeah, and I think Rick covered most of that. It'll need to have the wheels so that it can maneuver close enough to the samples to allow it to pick up. And it'll have to carry, as you said, a little grapple hook that'll allow it to pick up the grapple that's on the end of each of those sample tubes and carry them back, as you said, one at a time. The helicopter design that we're considering right now really is just only slightly larger than the Ingenuity. And when I say large, I mean a little more mass, because you do have to carry the wheeled system and the grapple. But the mass is really just a very tiny increment more than Ingenuity. We definitely want to build and take advantage of the technologies that we used on Ingenuity. It was a technology demo and yet has been fantastic. So we don't want to change any of that. We want to use what's worked on Ingenuity. So the first thing I really want to do is stress that right now the conditions on Mars are really not conducive to life. We really do not expect anything to be alive on the surface there today. Number one, it's extremely dry, it's extremely cold, and life there would be exposed to a really deadly radiation environment with very little atmosphere to protect anything on the surface. That radiation would likely, kill anything that were there on the surface. So it's highly unlikely. The probability of something being alive on the surface that could be dangerous is very small. That being said, we are still being very cautious. We are making sure that when the samples are launched into orbit and then transferred and captured into this capture and containment system on the Earth Return Orbiter, there's multiple layers of seals in there, so that we've done something we call breaking the chain, so that there's no chance of any of the Mars material actually getting outside of that Earth return system and coming into the Earth's atmosphere. All of the Mars material will be contained inside of that Earth return system. We've designed the entry system such that it doesn't even need to rely on a parachute. So one of the biggest risks we have on an atmospheric entry is that the parachute doesn't deploy properly. Well, we've said, let's just bypass the parachute altogether. We will just plan on a hard landing, and we've done many tests of landing a heat shield on hard desert floor, such as they will experience in the Utah desert when the sample return canister comes back, and maintain the integrity of the structure, and particularly the structure of that the sampling container that holds the samples. We'll then make sure that we have all the proper precautions in place as we open and disassemble the entry system. And make sure that we are keeping the sample contained until we're confident that it's safe to be handled and safe to be distributed for the scientific analysis. Will be, but we have processes in place for doing that, particularly through, the Apollo sample programs. We've also, of course, working extremely closely with European Space Agency. We are partners on this Mars sample return mission. And so the one thing that we are planning to do, which is a little different from normal, is that this will be a jointly owned sample, both Europe and the U.S. These are our samples. It will be a collection that is for everyone, and we will probably curate it in different places, but we'll have the process for allocating those. And absolutely, there are plans to preserve significant fractions of the samples for future. That's, as you said, that is the incredible value of these sample return programs that we have, is that we can save large fractions of the sample, as you say, for future analytical capabilities, for new hypotheses to be tested in the future that we don't even know to test yet. And we've seen that demonstrated with the lunar samples, with the most recent samples that were opened, almost 50 years after they were collected, still in their pristine sealed sample tubes. Fantastic opportunity to test new hypotheses and allow the new generations of scientists to look at those samples.